Hello everybody, this is Julian at Mecanum, and today we are going to talk about two very interesting topics, acoustic metamaterial and square impedance tube. So I will start the video by doing a quick overview of acoustic metamaterial. Then I will present you the advantages of using a square impedance tube, and we'll finish the video with a quick demonstration. As you probably already know, the prefix meta of metamaterial comes from the Greek, and it means beyond. So basically what it means is that a metamaterial is a complex arrangement of different solutions that you combine together, and the global performance goes beyond, surpass their individual performance. So if you want to simplify that, you can just see it as teamwork for materials. There are many answers to this question. Of course, you can use micro-perforated plate, you can use resistive screen, Helmholtz resonators, which are actually a pretty old solution. They were invented in 1850 by Mr. Helmholtz himself, and now they are being revisited in many articles. It's the same thing for quarter wavelength resonator. Quarter wavelength resonator are also a pretty old solution, but the interesting thing with them is that they don't necessarily need to be straight. So you can think of many applications where you can do circles or different geometry with them. Lately, many articles have come with a labyrinthine solution. So they open the door to many possibilities for acoustic metamaterial applications. You also have resonating mass that can be useful for transmission loss application, and sonic crystals. Sonic crystal, I personally really like this solution because they can easily be combined with other type of material. So when you have place, they can be very high performers, especially in duct application. And of course, any combination of the previous mentioned solution, even with a standard porous material, when well designed for a specific application, they can lead to very, very performant results. Well, with acoustic metamaterial, it's always a good idea to start with simulation. You can use your software Nova that can help you design many types of resonator, micro-perforated plate, resistive screen, and combine them together. But eventually, you will need to perform finite element simulation because of the geometry complexity. Once you have designed your solution, it's time to measure it. And that's where the square impedance tube comes into play. It's a great advantage to design metamaterial because it can reproduce the periodicity effect. In fact, because it's square, there are image sources that are created due to the reflection in the interior walls of the tube. It can also be a great tool to design square duct solution and, of course, to accommodate square samples. At Mecanum, we offer two different sizes of square impedance tube. We have a 38 mm and a 100 mm, and they can both perform measurement in transmission loss using the 4-microphone method, and they are delivered with an end anechoic termination for better calibration and results. Another interesting solution that we offer is the square sample holder adapter. This sample holder can be used with a standard circular impedance tube. So this way it avoids you to have two different impedance tubes for your measurement. And in the software, we remove the effect of the adapters using a transfer matrix method. For the example today, we are going to test a sonic crystal solution in a 38mm square impedance tube. I'm now in TubeX interface. I will start by creating my project. We'll do a 4 microphone transmission loss project. I'll start by entering my environmental condition. Now I will select my impedance tube, so 38mm square with the standard microphone spacing. Here I can calibrate my microphone. For the example today, I will simply use the read TEDs button. Okay, and now I will calibrate my system. So I click on calibrate and I will use the microphone swap method well described in the standard, and I just follow the instruction that the software tells me. So now my calibration is complete. I'm ready to measure my samples. So today I will test a sonic crystal solution composed of 3 sonic crystals. I will install them in the sample holder. I'll start by opening the sample holder. We'll remove the door. Yep. And now in the bottom of my sample holder, I have a scale to help me position my samples. The position will be important in the software, so I will install them carefully. And now my 3 sonic crystals are well positioned. I'm satisfied with it, so I will close my sample holder, and it's as simple as that. Now I will add a measurement. Okay, the first step is to tell the software where my material is. So I will indicate the starting position and the sample thickness. And I will do my measurement on the first load, which is a hard wall in this case. Now I will do my measurement on my second load, which will be an anechoic termination. Now I'm happy with my measurement, so I will accept it. And now I can visualize my results. So there are many parameters that we can visualize. The most interesting for us today would be the transmission loss. So here you see this is the transmission loss of my measurement. So yeah, I reach a nice 20 dBs of TL at around 2600 Hertz. So now I could easily compare this solution to many other solutions using the compare measurement tool, or simply by doing more measurement in other configuration. Now, if we recap, a metamaterial is a combination of solutions with higher performance where they are combined than when they are alone, and their periodicity effect can be easily measured in a square impedance tube. Another very interesting topic that we didn't talk about in this video is that the diffuse field sound absorption of most metamaterial can be easily measured in an acoustic test cabin. So stay tuned on our next video where we'll cover this topic. Of course, if you are in a hurry, you can always reach out to us and we'll be very happy to have a chat with you. I hope this short introduction to the very wide world of acoustic metamaterial was useful for you. Thank you very much for listening and see you in the next Mecanum video.